Hello everyone, this is Olali, and now I'll go ahead and discuss the electrical activity in neurons. During rest, there is a negative membrane potential of minus 70 millivolt. So if you look in the inner side of the membrane, you will see that this is negatively charged in comparison to the outer side of the membrane. And if you measure the negativity, it's going to be minus 70 millivolt. Why do we have a resting membrane potential of negative 70 millivolt? There are three important reasons. Always the large negative ions are inside of the cell and not outside. Like the proteins and phosphates are negatively charged and they are found inside the cell, making the inner side of the membrane negative in comparison to the outer side. The second reason is the sodium potassium pump. Remember that the sodium potassium pump kicks out of the cell three sodium and gets only two potassium inside of the cell. So both sodium and potassium are positively charged. So here in one activity of the sodium and potassium pump, we lose one positive charge from the inner side of the cell. And that's why the inner side of the membrane is negative if you compare it to the outer side. The third reason is that the potassium leak channels are more active than the sodium leak channels. Remember that inside of the cell we have higher level of potassium, and outside of the cell we have higher level of sodium. All the time sodium tends to go from the higher side to the lower side, and potassium tends to leak from the higher side out to the lower side. But the potassium channels are actually more active than the sodium channels, so we lose more potassium than we gain sodium. This means that the inner side of the cell is going to be also negatively charged. So here the sodium is higher outside of the cell in comparison to the inside of the cell. So they tend to move from the higher to the lower side. If you look at potassium, it is higher inside of the cell, so they leak from the outer. So potassium leaks from the inside of the cell going outside of the cell, but again the potassium leak channels are more active. Actually they are 75 times active than the sodium leak channels. The cell membrane is excitable, meaning that the cell membrane is able to change potentials by changing the permeability to certain ions, by allowing positive or negative charged ions to enter or exit the cell. We have two types of channels. The ligand gated channels, so they respond to a chemical or neurotransmitter or a ligand found in the synapse. This neurotransmitter or ligand opens up ligand-gated channels, leading to movement of ions in or out of the cell. We have also voltage-gated channels, but they open only if the membrane potential becomes negative 55 millivolt, that we call the threshold level. So at the threshold level, the voltage-gated channels become active. The ligand-gated channels are responsible for something that we call graded potential, and the voltage-gated channels are responsible for the action potential. For this action potential to happen, a graded potential must happen first, getting the membrane to the threshold, which is minus 55 millivolt, and here the voltage-gated channels can open, leading to the action potential. So the changes in the membrane are depolarization, repolarization, and hyperpolarization. So during rest, the neuron is polarized, meaning that the inner side is different from the outer side. The inner side has a minus 70 millivolt charge, and the outer side is positive. Then depolarization, meaning that we are reversing that. So the inner side now is going to become positive. And this depolarization, which is making the membrane go to the positive side, happens in two steps. The first step happens from minus 70 to minus 55, and we call that the threshold potential, which is a graded potential. So here, neurotransmitter comes. The neurotransmitter opens up sodium ligand gated channels. So sodium enter the cell, getting the membrane up to the positive side until it becomes minus 55 millivolt that we call the threshold. At this point, action potential happens due to opening of the voltage-gated sodium channels, so more sodium goes in. What is repolarization? Repolarization meaning you are taking the membrane to the resting polarized potential. So the resting membrane potential is minus 70. So when you go down until you go to the resting potential, we call that repolarization. And this happens because potassium exits the cell. Potassium is positively charged. When it goes out of the cell, now the inner side of the cell goes down to the negative side until it goes to the resting potential, which is minus 70 millivolt. Then what is hyperpolarization? Hyperpolarization is when the membrane goes more negative than the resting state of minus 70 millivolt. So let's go step by step with the activity of the neurons. So the resting membrane potential is minus 70 millivolt. Then from minus 70 to minus 55, here is called graded potential or threshold potential. This happens due to the presence of neurotransmitter that opens up sodium ligand gated channels. So sodium goes on the side of the cell, getting the membrane up to minus 55 millivolt. And this is the threshold. At the threshold, what happens is the depolarizing phase of the action potential. So what kind of channels are active here? Here we have voltage-gated sodium channels. They open at the threshold. So sodium enters, taking the membrane up until it becomes plus 30 millivolt, which is the peak of that action potential. Then after the depolarization, we have repolarization. So the membrane goes down to the minus 70 millivolt, and this happens due to the activity of voltage-gated potassium channels. So potassium leaves the cell, and the membrane goes negative until it goes to the resting state of minus 70 millivolt. Then we have hyperpolarization when the membrane goes more negative than minus 70. So maybe here it's minus 90. And why does this happen? It happens because the potassium voltage gated channels are slow. They receive a deactivation signal when the membrane goes to minus 70. However, they do not respond until the membrane goes to minus 90 because they are slow. So hyperpolarization happens because the slow voltage gated potassium channels close at minus 90 rather than at minus 70 millivolt. So if you look here at the timing of the action potential, the depolarization happens in this time, comparing that to the time of the repolarization. Remember, the repolarization happens due to the activity of the voltage-gated potassium channels. And because they are slow, they still leak potassium out until the membrane goes more negative than the resting state of minus 70 millivolt. So the voltage-gated sodium channels are fast, leading to shorter time in the depolarization. However, the potassium voltage-gated channels are slow, and this leads to the hyperpolarization. Okay, now let's go with some review questions. So the resting membrane potential is how many millivolt? It's minus 70. What leak channels are more active than what leak channels? Remember that the potassium leak channels are more active than the sodium leak channels. So we lose more positive charge than we gain because more potassium exit than the sodium that enters. At what membrane voltage do neuronal voltage-gated channels become activated? The voltage-gated sodium channels become active when the membrane goes up at the threshold, which is minus 55 millivolt. What is the peak of the action potential? The depolarization goes up until the membrane becomes plus 30 millivolt. And at this point of time, repolarization happens. Hyperpolarization phase is due to what? It happens because the voltage-gated potassium channels are slow. Now, let's go ahead and describe the steps of the graded and action potential. First, the first thing that happens is that the action potential going down to the axon of the neuron causes what to enter the axon terminals. And when this happens, the neurotransmitter is going to exit out in the synapse. Remember that calcium must go inside the terminals of the axon to kick out the ligand or the neurotransmitter out in the synapse. Then that neurotransmitter will open up ligand gated sodium channels. Sodium goes until the membrane goes up to the threshold, which is minus 55 millivolt. At minus 55 millivolt, which is the threshold, what happens? What kind of channels become active? It's sodium voltage-gated channels become active. Then sodium enters until the membrane goes up to the peak, which is plus 30 millivolt. When the membrane goes to the peak, now we have the repolarization. Here, what kind of channels open? They are voltage-gated potassium channels. So potassium goes out of the cell, getting the membrane to the resting state of minus 70 millivolt. But because the voltage-gated potassium channels are very slow. They will continue to exit. The potassium will continue to exit until the membrane becomes more negative than the minus 70. Maybe it goes to minus 90 millivolt.